Okay, great. Yeah, so my name is Levi Exner, and I was the software development intern working with Doug Ertz this summer on the state of health plots. Um, yeah, so let's get started. So the state of health plots are, there are seven graphs that every 2 weeks um, they get plotted and uploaded. And so they're the health statistics of the GPS stations, mostly in the NODA network. And so the goal was to rewrite that into Python. Currently, or previously, they were in PHP, and it was just time to move them into a new language and a new plotting library, as well as migrate them to the new hardware, the new virtual machine. Here you can see this is two examples of the previous plots. This is the multipath for station P100, and then this is the daily ping rate of how many pings get sent from the station to the satellite. But yeah, this is the old PHP graphs. So the method we're going to use is Python, and then the matplotlib plotting library. We also considered using MATLAB, and which I'm sure some of you are familiar with, and Plotly, and then the PostgreSQL database, which all the data is stored in from the GPS stations. Let's see. One of the interesting problems is here you can see this is the multipath for two different stations. And so plots like a long period for the entire life of the station. It'll plot the multipathing. And so if there's like a very high point very at the beginning, as you can see of both of these, it just looks very small at the end because if you have the y-axis like this. And so controlling the outliers, like we tried to, or I tried to do, like exclude the top 1% and the ones that are below the 99%, but that would exclude, because there's hundreds of points, that would exclude more than just the one. Or the empirical rule, which is, how many standard deviation, or so 3 standard deviations away from the mean is 99.7 of the points are going to be within 3 standard deviations. And so we tried that as well, but again, it cuts out more points than just the one. Yeah, and then partway through working on the project, I guess the scope kind of changed because Doug realized that there's these weekly reports that will generate these plots. Instead of every 2 weeks, it'll be on demand for the date and time period that you choose. So it turns out we had to implement this deep linking, which is where you can see in this URL, the deep linking is where this variable q is assigned to hello. So if you search hello on Google, the query is right here in the URL. And so we need to implement that functionality in Python. And basically, so at this point, I'm already done kind of moving the PHP over to Python. And Python doesn't run natively in the browser. So to change the method, one of the first options we talked about was pyodide, which is basically it compiles Python to JavaScript, and JavaScript runs natively in the browser. But and then another option is Jupyter, which actually uses pyodide as a backend. And I think Jupyter is just the next step up because it's we wouldn't have to build a bunch of new stuff. But you can't do the deep linking where the parameters are in the URL in Jupyter. So you can't do that in Flask. And Flask is a way for, they call it microservices. But basically you host your own server and that'll serve up the image on the website. So here's some comparisons. So on the left, you can see is the old plots in PHP, and on the right is the new plots. And so the goal is to make them look, basically identical. Yeah, and then so let's see. And here's 2 more. then these last ones, this is the last two. Yeah. This one was fun. Okay, so this blue line on this one, it plots the voltage at the top, this green and yellow, and then another voltage on the bottom on both of them. But this one also has the temperature of the board, and we talked about moving that into its own like 8th plot, but I think it was okay to just kind of mute the color and move it to the back. Okay, so now I have this Flask implementation, and we could just show you like the deep linking. You could pick, do you see this window? I think so. So you can see this deep linking right here. And you give it a second, yeah. Or well, maybe you won't see it, but you can go ahead and write it in. Do a different station. Maybe that won't work though. Yeah. Maybe here. See, there you go. Okay, so there you can just type in this or have the parameter of the URL. So that way, when there's a URL in the weekly reports, it'll serve you up the image with the dates you put in. So, and then, okay, I'd like to acknowledge Doug Ertz for really giving me this opportunity. It was really nice to go into the office almost every day because I lived in Fort Collins, so I could just go into the Boulder office. And then I think at the end of like the spring semester, I wasn't totally sure if I wanted to make software development my career, but I could say after this internship that I'm pretty sure. So thank you. And then also the EC team and the rest of UNAVCO as well. Yeah, so are there any questions?
Thanks, Levi. Looks like Beth has a question. Or is your hand still raised from last time?
Sorry, I think it was still raised. Let me figure out how to get rid of that.
You have to repress it, I think. There you go. Okay, I have a question because my background is not in coding or anything that you talked about, although I did learn things just now, so thank you. My only question is, what was the motivation for moving it to Python? Like, it seemed like I should know, but I didn't know.
Yeah, so PHP, it's an older programming language, and basically it's not very intuitive. I think Python, it's very simple. It's like there's no like ampersands and dollar signs everywhere, and then it has a much richer scientific, or it has a lot more libraries for like scientific work, I think, as well, compared to PHP. And so just between those two factors, I think that's why we settled on Python, which is actually a good question, because I think at the end, after doing it all, because there ended up being this browser component, we could have done the plotting and stuff, at least in part in JavaScript. So that's something to consider.
Anika, can I butt in here? Just a quick.
Yeah, please do.
The reason we moved it, one was it was on an old piece of hardware and we needed to move it. So that was one reason. But the other thing was the speed at which we were able to produce these graphs. So Levi took it from 8 days to 8 hours. So
what was it, 8 days? I thought it was 3 days. That's
no,
great.
8 days. So that was a big reason as well.
Wow. Yeah, that is significant.
And part of that is just because it's on newer hardware as well. So.
Well, you also multi-processed it as well.
Yeah. Yeah, well, great. Thank you, everyone.
Christine has a question.
Mhm.
She says, she might have missed it, but are the QC numbers being pulled from, oh man, fancy words, I don't know, Tech QC files or the database, which I think gets its numbers from the Tech QC files?
It's from the database, and all that data is from like the receivers, like the NetRS. I'm not sure exactly. Maybe Doug could speak.
Yeah, they come from Tech QC. So the answer is both, I guess, because the database pulls them from Tech and Levi's code pulls them from the database.